Modern commerce relies on a vast, deeply intertwined network of manufacturers, ports, and transit routes. If a single factory goes offline or a canal gets blocked, the delay doesn't stay local. It ripples outward, stalling operations thousands of miles away. When sudden spikes in demand or labor shortages hit international shipping ports, massive container ships end up stacking up outside harbors, unable to unload. The entire flow of physical goods hits a hard physical limit. For the person at the end of the line, that distant shipping backlog translates to empty grocery shelves. The products they need simply aren't there. It doesn't always take a global event to cause this. Even localized infrastructure issues, like rolling power outages, can shut down a crucial manufacturing hub, temporarily knocking out a vital link in the chain. For decades, companies managed these networks by reacting. They waited for a port to close or a supplier to fail, and then scrambled to find alternatives. By the time a fix is finally put in place, the financial losses have already compounded. Building a rigid, heavily fortified logistics network fails because it cannot bend. When unpredictable pressure is applied, a system without flexibility simply shatters. Supply chain managers are abandoning that wait-and-see approach. They are now working to orchestrate their networks proactively, adjusting variables before a bottleneck ever forms. The primary tool driving this foresight is predictive analytics. By feeding massive amounts of real-time data into advanced models, organizations can easily spot incoming disruptions on the horizon. These algorithms ingest highly disparate data from across the globe. They track severe weather systems, analyze local news feeds, and monitor competitor activity, synthesizing it all to map out likely future scenarios. The value of this capability is driving massive investment. The market for predictive analytics in supply chains is projected to grow to $38 billion by 2028. Assessing the damage after a crisis has passed is no longer a viable business strategy. Organizations have to see the threat coming and route around it. At the core of these predictive systems is machine learning. These artificial intelligence algorithms are designed to dig through years of historical supply chain records and constantly streaming data to discover hidden patterns and flag anomalies. This diagram shows a mapped supplier network operating in real time. When applied to risk management, the software constantly monitors vendor delivery times and financial health. If a specific manufacturer shows signs of an imminent slowdown, the system flashes a warning and immediately maps out alternative pathways. In studies of complex asset manufacturing, where thousands of specific parts are required to build a single product, these models correctly forecast late component orders with an accuracy rate approaching 80%. During the COVID-19 pandemic, data storage company Western Digital relied on a predictive risk engine to monitor their global network. This early warning system allowed them to protect their operations from the massive logistical shutdowns that crippled other tech manufacturers. Spotting a supplier's failure days or weeks in advance gives a company the lead time to secure alternate materials and adjust manufacturing schedules. The disruption is bypassed entirely, and the end consumer receives their product on time. Beyond managing supplier risk, predictive data also solves the problem of where to physically place goods. Storing excessive safety inventory creates tremendous financial waste, while understocking leads to lost sales. To find the exact right balance, one of the largest consumer goods companies in Indonesia deployed a gradient boosting model. This machine learning technique predicted specific regional inventory needs with up to an 84% accuracy rate, allowing them to place the exact amount of stock right where it would be bought. Once that product is in motion, logistics providers like UPS use predictive routing to minimize transportation costs. By feeding distance, weather, and live delivery points into their models, the software calculates a highly efficient route that lowers fuel consumption and avoids sudden traffic jams. To prepare for large-scale disruptions, companies are building digital twins, exact virtual replicas of their physical supply chains. They can subject these digital networks to simulated pandemics or extreme weather, allowing them to stress test their response strategies without any real-world risk. Accurately forecasting consumer demand and running these advanced logistical simulations turns a supply chain from a heavy, expensive burden into a highly agile competitive advantage. But all of this advanced technology carries a strict requirement: data quality. If an algorithm is fed historical records full of errors, duplicates, or missing variables, its predictions will be completely useless. Implementing these systems also means navigating strict data security regulations to protect sensitive information. Internally, management frequently has to overcome deeply rooted organizational resistance from staff who are used to manual ways of operating. Purchasing expensive AI software doesn't automatically solve these problems. Digital transformation requires an organization-wide commitment to data mastery, prioritizing clean information and continuous training. When fully integrated, the supply chain operates like a living system. It constantly ingests new information, learns from shifting market dynamics, and automatically adapts its workflows to minimize exposure to risk. The global market practically guarantees that another major disruption is always looming. Predictive analytics provides the foresight to navigate that chaos, separating the companies that can seamlessly pivot from the ones that get left behind.